Welcome back to Algebra 1. We are going to talk about Chapter 6, Section 5 in this book, graphing linear equalities in two variables. Doesn't that sound fancy? We're getting to do fancy math. This is just fun. Alright, so we have been solving inequalities where there's an x and a bunch of numbers and we solve it. But now we're adding y. And you know, if it's got an x and a y with no exponents, then you could graph it and it's a line. Well, it turns out even if it's an inequality, it is too. Now, there's one little trick, and that is if it is greater than or less than and equal to, you draw a solid line. If it's just less than or greater than, you draw a dotted line. And I remember being your age and forgetting that and losing points on the test and getting so mad because it was one of those little nitpicky things. But the reason why is it's the equivalent of our dot and donut. The donut is just less than, the dotted line is that. It's broken, it's not all filled in. The or equal to is the dot or the solid line. It's all filled in because it includes that point, that point there. Hopefully that'll make more sense as we go. Alright, so here's a typical one. And if we were going to graph it, then we do like what we always do and do an if-then chart. And we're going to do it the cheater pants way. So we say if x is 0, it goes away. Then we would, y is a y not alone, it's being multiplied by -3, so we're going to divide both sides by -3. The two negatives cancel out and make it positive, and we get positive 2/3. Now, we're not worried about flipping anything at this point. We don't do that. We're just getting these points so we can make our graph, okay? So now we do it the other way. What about if y is 0? Then that goes away. The reason why x is not alone is it's being multiplied by 2, so we divide by 2. What I do to one side, I do to the other. -2 divided by 2 is -1. So now I've got my points. I have a point of x is 0, y is 2/3. We'll put it right there. And if x is -1, y is 0, it goes right there. I can make a line. It's a solid line because of that or equal to. Okay? Now then, what you do is you color the one side of it. One side will be colored and the other one won't. It's just like how we colored on our number line, we have to figure out which side of the line here to color. But remember when we did equations for the first time, we didn't start solving the equations and graphing them. First we did, is a certain point a solution of the equation, and we would plug it in and see if it was or not. And remember I told you you do those at the very beginning and then you don't do them again. Sort of same thing here. Alright, so let's do it not knowing which side to color yet, but just plugging this into this equation and seeing if it makes a true statement. If it makes a true statement, that point got colored. So, we're going to substitute in 0 for x and 0 for y. 0 times 2 is 0. 0 times -3 is 0. So this makes the statement 0 is greater than or equal to -2. Is that a true statement? Is 0 bigger than -2? Yes, it is. So that means that that point 0, 0 is in the colored part. And we know that our line here is going to get colored. Ta-da! Like that. Okay, let's try another point. 0, 1. X is 0, y is 1. This point is right here. Now, by looking at our graph, we should see that it should be no. Let's make sure. Okay, if x is 0, 2 times 0 is 0. If y is 1, 1 times -3 is -3. Is -3 greater than -2? No, it's not. It's less than. You're worse off if you owe me $3 instead of $2. That makes sense? Okay, let's try this one. X is 2, y is -1. This one should make a true statement because it's in the blue part. Do you see that? So let's try it. X is 2, 2 times 2 is 4. Y is negative 1. Negative 1 times negative 3 is positive 3. And so what we're saying is 7 greater than or equal to negative 2. Yes, it is. That part's in the colored part. All right, so let's let's show you how to graph these. If you have x is less than 2, negative 2, you go on the x-axis to negative 2 and put a dot. Then you say to yourself, no matter what, y can go up or y can go down, but x is negative 2. And because it is not or equal to, it's a dotted line. Y can go up or y can go down, but x is less, gotta do the less than side, is less than negative 2. Now let's do this one. Y is less than or equal to negative 1. So we go to y equals negative 1 and we put a dot. Then we're going to do a solid line because of that, and we say no matter what, x can go up or x can go down, but y is negative 1. And y is less than negative 1, so we're going to color the less than side. Now, one of the really fun things about this is your calculator will do all this for you. And so you have to be sure you watch that video. And I have the colored calculator, so I can do it in colors even. I know you have calculator envy. Try to control it. All right, let's do another one. We'll do this one right here. Before we can do it, x has to be alone. Why is x not alone? It's being multiplied by 4. So we have to divide both sides by 4, and we don't flip it because it's a positive 4. X is greater than or equal to negative 3. So I'm going to go to negative 3, negative 1, negative 2, negative 3, put a dot. I meant to do this in black. Get a new color here. Put a dot. Where it's going to be a solid line. Y could go up or y could go down, but x is negative 3. And x is greater than negative 3, so I'm coloring the greater than side of it. And I always think it's fun when you put it all on one and it looks so complex. Alright, so now let's do this one. X plus y is greater than 3. So this has got an x and a y. We need an if-then chart so we can get some points so we can draw our line. So first we're going to start with if x is 0, it goes away, and y is greater than 3. We just write the 3, we don't worry about the greater at this point. Now what about if y is 0? It goes away, and x is 3. So we can put these points on here. If x is 0, y is 3, put a dot. If x is 3, y is 0, put a dot. It's going to be a dashed line because there's no equals under there. Okay, and now we have to figure out which side to color. There's really two ways to do it. One way is you find a point that's not on the line and you test it. 0, 0 is not on the line. Let's see if it makes a true statement. Okay, so 0 plus 0, is that greater than 3? Well, 0 is not greater than 3. I'd much rather have $3 than $0. So I need to color the other side, not that side because it made a false statement. The other way to do it is actually to solve for y. So we're going to get y by itself by doing minus x and rewrite our equation. Y is greater than negative x plus 3. And it tells us that on y, I need to color the greater end. That's the other way to do it. I like this way better because sometimes it's hard to figure out what point to use. Sometimes they get complicated. I like solving for y. Also, that's the way you're going to put it in your calculator and check it with your calculator. Okay, last one. If x is 0, whoops, I wrote the problem wrong. I put 2 x's. Let's see what it really was. It is x plus y is greater than, oh, I got it out of the homework because I wanted to do one of those. We'll just, that one's supposed to be y. There we go. All right, if x is 0, y is negative 1 Gotta divide both sides by -1. 2 negatives 1 equals a positive 1, because 2 negatives cancel out. And if y is 0, then x, divide both sides by 2, is -1/2. So if x is 0, y is 1, put a dot. If x is -1/2, y is 0, put a dot. Your line needs to be solid because of the or equal to. And now we need to see which side to color. We'll try 0, 0 and see if it gets colored or not. 2 times 0 is 0, minus 0 is 0. So is 0 less than or equal to -1? No, I'd much rather have $0 than owe you $1. So this should not be the point, it should be this side. The other way to do it, you solve for y, do minus 2x from both sides, and then you get negative y is less than or equal to -2x minus 1. Divide by -1. Who gets divided by -1? Everybody. And we have to flip it. So y is greater than or equal to 2x plus 1. Y is greater than, we color on the y-axis the greater than side. Alright? Not terrible, but you better practice it or you won't be able to do it. And these problems are on the SAT, ACT, and college entrance exams, so you need to learn them. Math is great. See you later.